Hi guys, let's start a new chapter. This is chapter number 8, which is called Remainder and Factor Theorem. Now, before we go ahead and look at the new concept in this chapter, let's quickly look at things which we already know. So, let's say fx, which is read as function of x, is equal to a polynomial which is x squared plus fx plus 8. Why is this? Why did I say function of x? Basically, it means that this polynomial depends on x. Why does it depend on x? Which means if I change the value of x, the value of this polynomial will change. So let's look at this. If x is equal to 1, what will be the value of this polynomial? Right? So that will be, instead of x, I write 1. So that's 1 square plus 5 into 1 plus 8. So that's 1 plus 5, that's 6 plus 8, 14. Which means the value of this polynomial when x is 1 is 14. Now let's look at the value of this polynomial or the function of x when the value of x is 2. So if value of x is 2, then this is 2 square plus 5 into 2 plus 8. That's 4 plus 10 plus 8, which is 22. So you notice that the value of this polynomial changes depending on the value of x. Obviously, that's why this is read as function of x. It depends on x. Good. Now let's, before I get on to the concept of remainder theorem or factor theorem, let's go ahead and divide this polynomial x square plus fx plus 2 by x minus 2. Why are we doing that? I'll come to it in just a minute. So let's go ahead and divide it. So this is x square plus f5x plus 8 divided by x minus 2. To get x square, I'll multiply it with x. So this gives me x square minus 2x. Now I subtract, which means the signs will change. X square gets cancelled. That's 5x plus 2x. That's 7x plus 8. Now I'll multiply this with 7. So that will be give me 7x minus 14. Again, sign changes. 7x gets cancelled. And 8 plus 14, that's 22. Good. Let's divide the same thing by x minus 1 as well. Why are we doing this? I will come to it in just a minute. Right. So let's divide the function of x, the polynomial that we took, by x minus 1. So the first term will be x. This will give me x square minus x. When I subtract, the sign changes. X square minus x square gets cancelled. That's 5x plus x. That's 6x plus 8. Now I multiply it with 6, so that's 6x minus 6. Again subtract, 6x and 6x gets cancelled, 8 plus 6, that's 14. I hope you notice something, right? The remainder, when we put the value of f as 1, is the value of f1 was 14, and when we divided it by x minus 1, the polynomial, the remainder was also 14. Okay, let's try if it worked for 2. The function, if x was equal to 2, so the polynomial, if f was equal to 2, the value was 22, and we divided it by x minus 2, the remainder was also 22. What it means is that when a polynomial fx is divided by x minus a, in this case x minus 1, the remainder is fa. So when you divide it by x minus a, the remainder is function of a. So in this case, we divided it by x minus 1. The value of a was 1. So the value of the remainder is equal to, if instead of x, you put 1. So instead of x, if I put 1, the remainder is 14. What does it do? It helps us not do the actual division, and still figure out what will be the remainder, right? So had I not done this division at all, I could have told you, if you divide x square plus 5x plus 8 by x minus 1, the remainder will be 14. So it uh, reduces the step of dividing, and it gives us the remainder directly. Let's look at what we did for the second one. So it says, if the polynomial is divided by x minus a, then the remainder is f of a. In this case, the second case, our a was 2. So what we had was, uh, we divided it by x minus a, which is x minus 2, and the remainder was f of 2. In this case, it was 22, and when we divided it by x minus 2, the remainder was still 22. Okay, I hope this part is clear. The remainder can be figured out without actually dividing a polynomial by x minus a. The remainder will be f of a. Let's look at some questions. Before we start questions, maybe we can also look at what the factor theorem is. So let's do the same thing again. Now in this case, the polynomial that we have been given is x square minus 5x plus 6. Let's try and figure out the value of the polynomial when x is equal to 2. So if I put this, that'll be 2 square minus 5 into 2 plus 6. That's 4 minus 10 plus 6. That's 0. Which means, if I remember my remainder theorem, if I divide x square minus 5x plus 6 by x minus 2, my remainder will be 0. Let's try it when the value of x is 3. This will be 3 square minus 5 into 3 plus 6. That's 9 minus 15 plus 6. Again, that's equal to 0. Which means if I were to divide it by x minus 3, my remainder will still be 0. Okay, let's see if we can do the actual division and still get the same answer. So x square minus 5x plus 6, this is what our remainder theorem tells us. Let's go ahead and prove it using actual division. So divided by x minus 2, that gives me x square minus 2x. Let's subtract. X square gets cancelled. That's negative 3x plus 6. I multiply it with negative 3 and I get negative 3x plus 6. Sign changes and this is 0. That's exactly what we had predicted. If we were to divide x square minus 5x plus 6 by x minus 2, our remainder would be 0. What this also means is that x square minus 5x plus 6 is completely divisible by x minus 2, which means x minus 2 is a factor of x square minus 5x plus 6. Yes, that's correct. X minus 2 is a factor of x square minus 5x plus 6. Now, if the remainder is 0, then it's obviously a factor. Let's see if we can do the same thing by x minus 3. In fact, you notice this is x minus 3 multiplied with x minus 2. So we should get the answer, but still let's go ahead and divide it. X square minus 5x plus 6 divided by x minus 3. So this is x square minus 3x minus plus, gets cancelled. That's negative 2x plus 6 multiplied with negative 2. You get negative 2x plus 6, which is 0. So the remainder, if you divide x square minus 5x plus 6 by x minus 3, is 0, which means x minus 3 is a factor. Right. So that brings me to factor theorem. Factor theorem states when a polynomial fx is divided by x minus a. In this case, we divided it first by x minus 2. Remainder is fa. In this case, remainder of f2 was 0. And if f2 is 0, then x minus a is a factor of the polynomial fx. Basically, remainder theorem and factor theorem are exactly the same. It says if a polynomial is divided by x minus a, then remainder is equal to f of a. And if remainder is 0, then x minus a is a factor of the given polynomial. Perfect. Let's go ahead and solve some questions. Maybe the concept will become even more clear. Okay, the first question says, find the remainder when x to the power 4 minus 3x square plus 2x plus 1 is divided by x minus 1. Again, I don't need to actually go ahead and divide it. I can figure out the remainder directly by using the remainder theorem. So how do we solve it? So by remainder theorem, we have x minus 1, which means let's equate it to 0, which means I get the value of x is equal to 1. So remainder will be equal to f of 1. In this case, let's put the value of x as 1. So f of 1 will be equal to 1 to the power 4 minus 3 multiplied with 1 to the power 2 plus 2 multiplied with 1 plus 1. This is 1 minus 3 plus 2 plus 1. this is equal to 1. So if you divide x to the power 4 minus 3x squared plus 2x plus 1 by x minus 1, my remainder will be 1. Therefore, remainder is equal to 1. Right. So I hope you realize the first step was you figure out the value of a. In this case, this is x minus a. So a is equal to 1. All right. So that's what you do. X minus 1 is equal to 0, which means x is equal to 1. In this case, we're looking at a is equal to 1. Basically, this is you dividing it by x is equal to x minus 1. So the value of x is 1. This is what you put in the given polynomial. Replace x with 1. When you replace x with 1, what you get is 1 to the power 4 minus 3 into 1 to the power 2 plus 2 into 1 plus 1, and the remainder is 1. Okay, similar question. Let's do it when x to the power 4 plus 1 is divided by x plus 1. So by remainder theorem, what we have is x plus 1 is equal to 0, which means x is equal to negative 1. Now, remainder will be equal to value of polynomial when x is equal to negative 1, right? Which is basically what we write as f of negative 1. So instead of x, I put negative 1 to the power 4 plus 1. And this is 1 plus 1, which means the value is 2. Therefore, remainder is equal to 2. Good. Let's look at the next question. The next question is question number 2, part 1. It says show that 3x plus 2 is a factor of 3x squared minus x minus 2. So by factor theorem, 3x plus 2 will be a factor if value of polynomial when x is equal to negative 2 by 3 is 0. Right? Why did I get x is equal to negative 2 by 3? What is given is 3x plus 2 is equal to 0, which means x is equal to negative 2 upon 3. Right? So when the value of x is negative 2 by 3, the value of the polynomial should be 0. Only then it will be a factor. So let's substitute value. 3 multiplied with negative 2 by 3 whole square minus negative 2 by 3 minus 2. So this will be equal to 3 multiplied with, that's negative 2 square, that's 4, 3 square, that's 9, and this is plus 2 upon 3 minus 2. 3, 1, 3, 3. So this is, let's take the LCM. The LCM is 3. We have 4 plus 2 minus 2 into 3, that's 6, which is 0 upon 3, which is equal to 0. So since remainder is 0, I don't have space, I'll write it here. Since remainder is equal to 0, therefore 3x plus 2 is a factor. Right, let's go ahead and look at the next question. The next question that we do is question number 3. Question number 3 says, use the remainder theorem to find which of the following is a factor of 2x cubed plus 3x squared minus 5x minus 6. Okay, so what's given is fx is equal to 2x cubed plus 3x squared minus 5x minus 6. In the first case, x plus 1 is equal to 0, which means x is equal to negative 1. Let's figure out the value of f is equal to f negative 1. That will be 2 times negative 1 cube plus 3 times negative 1 square minus 5 times negative 1 minus 6. This is negative 2 plus 3 plus 5 minus 6. That's 8 minus 8, 0. So since f of negative 1 is equal to 0, therefore x plus 1 is a factor. Yeah, it will be a factor only if the value of the polynomial when x is equal to negative 1 is 0, is a factor. Next, let's look at 2x minus 1. In this case, what we have is 2x minus 1 is equal to 0, which means x is equal to 1 by 2. Let's calculate the value of f of the polynomial when the value of x is 1 by 2, there will be 2 multiplied with 1 upon 2 cube plus 3 multiplied with 1 upon 2 square minus 5 into 1 by 2 minus 6. That's 2 multiplied with 1 upon 8 plus 3 multiplied with 1 upon 4 minus 5 upon 2 minus 6. That's 1, 4. Let's take the LCM. The LCM will be 4. So this will be 1 plus 3 minus 10 minus 24. Yes, that's 1 plus 3 minus 10 minus 24. That's 4. That's negative 20, negative 30 upon 4. So since f of 1 by 2 is not equal to 0, therefore 2x minus 1 is not a factor. It will be a factor only if the remainder is 0. The last one, this says x plus 2 is equal to 0, which means x is equal to minus 2. Let's figure out the value of the polynomial when x is equal to negative 2. We get 2 times negative 2 cube plus 3 times negative 2 square minus 5 times negative 2 minus 6. 2 times negative 2 cube, that's negative 8 into 2, negative 16, and that's negative 4 into 3, that's not negative 4, that's 4 into 3, that's 12, this is 10, this is 6, this is 22, this is negative 22 is equal to 0. So since f of negative 2 is equal to 0, therefore x plus 2 is a factor. Good, let's look at the next question. The next question that we are doing is question number 4, part 1. It says if 2x plus 1 is a factor of the given polynomial, find the value of a. Okay, let's go ahead and solve it. So by, before we say, okay, yeah, by factor theorem, we have 2x plus 1 is equal to 0, which means x is equal to negative half. Now, since 2x plus 1 is a factor, therefore f of negative half will be equal to 0. Next, let's find the value of the polynomial when x is equal to negative half. So 2 times negative half whole square plus a times negative half minus 3 is equal to 0. Right? The value of the polynomial when x is equal to negative half will be 0 since 2x plus 1 is a factor. Let's go ahead and find the value. So this will be 2 into 1 by 4 minus a upon 2 is equal to 3. Yeah, I have taken 3 on the other side. Let's see what do we get. So we have, this is 2, 1, 2, 2. So this is 1 by 2 minus a by 2 is equal to 3, which means let's take the LCM, that's 2. So this is 1 minus a is equal to 3. This gives us 1 minus a is equal to 6, which gives us 1 minus 6 is equal to a. Therefore, a is equal to negative 5. So when the value of a is negative 5, 2x plus 1 will be a factor of the given polynomial. I hope you realized we started with by saying by factor theorem, we figured out the value of x. In this case, x was equal to negative 2. 2x plus 1 will be a factor only if the remainder is 0. In this case, we can find the remainder by putting the value of x is equal to negative half in the polynomial, and we found the value of a, which was negative 5. Next question. The next question that we have is question number 5. It says, find the value of constants a and b when x minus 2 and x plus 3 both are factors of the expression. So we have two factors given. Let's figure out what will be the remainder, because the remainder will be 0. So using factor theorem, we have x minus 2 is equal to 0, which means x is equal to 2. Now since x minus 2 is a factor, therefore f of 2 should be equal to 0. Let's replace the value of x as 2 in the given polynomial. So f of 2, which is equal to 0, should be equal to 2 cube plus a times 2 square plus b times 2 minus 12. So this is 2 cube, that's 8, plus 2 square 4a plus 2b minus 12 is equal to 0. Yeah, the remainder is 0. So 4a plus 2b, 4a plus 2b, 8 minus 12, that's negative 4. If I take it on the other side, that's 4. Let's divide both sides by 2. I notice 2 is common. So we have 2a plus b is equal to 2. That's my first equation. Good. Maybe we will be able to get a second equation and then we'll have to solve these two equations simultaneously. Okay, next one, which is x plus 3 is equal to 0, which means x is equal to negative 3. Now, since x plus 3 is a factor, therefore f of negative 3 should be equal to 0. Next, f of negative 3, which is equal to 0, is equal to 3 cube plus a times 3 square plus b times 3 minus 12. 3 cube, that's 27, plus 9a plus 3b minus 12 is equal to 0. This gives us 9a plus 3b. 27 minus 12, that's 15. When I take 15 to the other side, that's negative 15. Yes, that's correct. When I take it to the other side, that's negative 15. Or have I done something wrong? I have done something wrong because I have taken the value of x as negative 3, whereas here I have put only 3. So let me erase this and let me redo. Right? That's why I say you need to be very careful when you're solving questions. Okay. So f of negative 3 is equal to 0. Let's put the value of x as negative 3, which is negative 3 cube plus a times negative 3 square plus b times negative 3 minus 12. What this gives me is negative 27 plus 9a minus 3b minus 12 is equal to 0. That gives me 9a minus 3b. Negative 27 minus 12, that's negative 39. When I take it to the other side, it becomes plus 39. Dividing both sides by 3, I get 3a minus b is equal to 13. That's my second equation. So now I have two equations, two simple equations. Let's go ahead and solve them simultaneously. So that's point number 13. We have 2a plus b is equal to 2. 3a minus b is equal to 13. B and b gets cancelled. So we have 5a is equal to 15. Therefore, a is equal to 3. Now put a is equal to 3 in equation number 1 and we get 2 into 3 plus b is equal to 2. B is equal to 2 minus 6. Therefore, b is equal to negative 4. So they wanted us to figure out the value of a and b. So a and b is equal to 3 comma negative 4. Let's read the question. Find the value of the constant a and b. That's 3 and negative 4. Good. So first we did used factor theorem with x minus 2. We got a equation. Then we used factor theorem with x plus 3. We got an equation and then we solved these two equations simultaneously. That brings me to the last question of this video, which is question number 6. It says find the value of k if 2x plus 1 is a factor of the given polynomial. Okay, so using factor theorem, what we have is 2x plus 1 is equal to 0, which means 2x is equal to negative 1, which means x is equal to negative 1 upon 2. Now since 2x plus 1 is a factor, therefore f of negative half will be equal to 0. Now let's substitute the value of x as negative half and see what does this give us. So f of negative half is equal to 0, which is equal to 3k plus 2 multiplied with negative half to the power 3 plus k minus 1, which is 3k plus 2 multiplied with negative uh, 1 upon 8 plus k minus 1, and this is equal to 0. So what we have is 3k plus 2 minus upon 8 plus k minus 1 is equal to 0. Let's take the LCM. The LCM will be 8. So what we have is negative 3k minus 2 plus 8k minus 8 is equal to 0. Let's reconfirm. Yes, that's negative 3k minus 2. We'll multiply this with 8. So that's 8k and minus 8 is equal to 0. So we have negative 3k plus 8k. That's 5k. Negative 2 minus 8. That's negative 10 is equal to 0, because I have cross multiplied 8 into 0 gives us 0, which means 5k is equal to 10. Therefore, k is equal to 2. So the value of k is 2. If k is 2, then the given polynomial will have 2x plus 1 as a factor. I have marked a couple of homework questions. I hope you liked the video. If you have any questions or queries, feel free to write into me. Bye bye.